Hello students, welcome back to the 7th video of this playlist. In this video, we will be solving question number 7 from the recent past paper of Pure Mathematics 1, which is the October 2023 P1 paper. So let's get started with question number 7. Okay, so in question 7 it says the curve C has equation y equals to f of x where x greater than 0, given that f dash x, the gradient function of f of x, it is 4x squared plus 10 minus 7x to the power half over 4x to the power half. The point P with x coordinate 4, y coordinate -1 lies on the curve C. Fine. So part A, part A1, it's asking to find the value of the gradient of C at P. So we just need to find out the gradient of the curve C at the point P. So the gradient function, it's given. So we will use this gradient function. So at P, the x coordinate is what? The x coordinate, it's basically 4. So f dash 4, we will just substitute x equals to 4 into the gradient function. So you will get 4 times 4 squared, which is 16, plus 10 negative 7 square root of 4, divide 4 square root of 4. Okay, so now just do the calculation. 16 times 4, which is 256. Sorry, this is 64, not 256. Plus 10 minus 7 times 2, it is 14 over 4 square root of 4 is 8. So 64 plus 10, it is 74, minus 14, it is 60. So 60 over 8, that would give you 15 over 2. So the gradient of the curve C at P, it is 15 over 2. So this is part A1. So gradient of the curve, it is m equals to 15 over 2. That's it. That's what part A1 has asked for. Fine. Okay, next is part A2. Hence find the equation of the normal to the curve C at point P, giving your answer in the form ax plus by plus c equals to 0, where a, b and c are integers to be found. Okay, so we need to find out the equation of the normal. Okay, so a normal, it's basically perpendicular to the curve. So since it's perpendicular to the curve, so the gradient of perpendicular, that is the gradient of the normal, would be negative reciprocal of the gradient of the curve at the point P. So for part 2, the gradient of the normal, it will be negative reciprocal, which is negative 2 over 15. Okay, and it passes through the point P definitely. So equation, they wanted the equation of the normal. So equation would be y minus y1. The y coordinate of point P, it is plus 1, it is minus 1. So y minus 1, it will make it plus 1. This is equals to m times x minus x1. x1 is 4. Okay, since we know the coordinates of point P, which lies on the curve, which lies on the normal, and we figured out the gradient of the normal using the gradient of the curve at point P, so we can easily find out the equation. So to represent it in the form of ax plus by plus c, multiply both sides by 15. So 15y plus 15 equals to negative twice of x plus 8. So take all the terms on the left side. So negative 2x will become positive 2x plus 15y plus 15 minus 8. So plus 7. This is equals to 0. So this is the equation of the normal to the curve C at point P. We got 2x plus 15y plus 7. So here a equals to 2, b equals to 15, and c equals to 7. That's it. That's what part A 2 has asked for. Fine. Okay, next is part B. In part B, the question is asking to find f of x. Okay, so here we are given with the gradient function of the curve C. So we know that gradient function is basically found by differentiating the f of x, right? So that means if we do the opposite of differentiation, that is if we do integrate f dash x, we will get the original function, that is f of x. So that's what we will do here. We will integrate f dash x. So for part B, f of x would be integration of f dash x dx. So let's integrate f dash x. So the equation for f dash x, it is 4x squared plus 10. So 4x squared plus 10. So let's simplify it. So 4x squared over 4x to the power half over 4x to the power half, and then plus 10 over 4x to the power half plus 10 over 4x to the power half, and the last term, it is negative 7x to the power half, negative 7x to the power half over 4x to the power half. So we can easily simplify it, dx. Okay, so f of x would be 4 over 4, it cancels out, so x to the power 2 minus half, that would give you 1.5, which is 3 over 2, plus 10 over 4, it is 5 over 2, and x is in the denominator, so x to the power half. So x, since it is in the denominator, so it will be x inverse half, and then negative 7 over 4 x to the power half, and in the denominator x to the power half cancels out. So we have to integrate this expression to get f of x. Okay, so if you integrate x to the power 3 over 2, integration is the opposite of differentiation. In differentiation, we multiply the coefficient of the variable by the power of the variable. So in integration, what we will do, so after multiplying the coefficient in differentiation, we subtract 1 from the power. So in integration, we will add 1 with the power first. So x to the power 3 over 2 plus 1, that would give you 5 over 2, and then use the new power to divide the coefficient. So 1 over 5 over 2, so it will get what? Inversed, 2 over 5. Same goes for the second term. We will add 1 with the power, so it will become x to the power half, and then use the new power to divide the coefficient. So 5 over 2 over half. So 5 over 2 times 2, it is just 5. Okay, then negative 7 over 4, since it is x to the power 0, so it will now become x to the power 1. Okay, and the rule of integration is that when you integrate in indefinite integral, you have to add a c, which is the lost constant from the differentiation method. Okay, so we got the equation for the function f of x, but only c is unknown. So c, the constant, the unknown constant, it can be found using the coordinates of point P, because point P lies on the curve C. So coordinates of point P, it's 4 minus 1. So we will use these coordinates to find out the value for C. So 2 over 5 times square root of 4 to the power 5 plus 5 square root of 4 negative 7 over 4 times 4 plus C, this is equals negative 1. Okay, so square root of 4, it is 2, and 2 to the power 5, it's 32. So 32 over 2, it is 32 times 2, it is 64 over 5 plus 10 minus 7 plus C equals to negative 1. Okay, so make C the subject to get the to get the value for C. So 64 over 5 plus 10 minus 7, it gives 79 over 5. So C equals to negative 1, negative 79 over 5, so which is negative 84 over 5. So we got the function f of x the equation for the function f of x, we got 2 over 5 square root of x to the power 5. X to the power 5 over 2 can be written as square root of x whole to the power 5 plus 5 square root of x minus 7 over 4x, and then the value for c, it is negative 84 over 5. Negative 84 over 5. That's it. That's the equation of the function f of x. And that's what part B of question number 7 has asked for. Fine.